Hi, everyone. Welcome to our next Software and Content Thought Leadership Series webinar. This is on open source community development, achieving broad impact with your open source projects. So before we get started with the webinar, I just want to give a quick intro to our office, Innovation Partnerships, for those of you who haven't worked with us before. We are a connector for researchers who want to amplify the impact of their research through partnerships with industry and other external stakeholders. We do this through corporate-sponsored research, licensing, which includes commercialization, as well as broad dissemination of your projects, such as open source, and startup company formation. This is our website for the Software and Content Thought Leadership Series. Past recordings can be found here, and the recording for this webinar will also be posted here. And then I just want to draw your attention to a pilot initiative that we're rolling out in the fall. It's called MOS, Michigan Open Source Software. And the goal of the initiative is to provide comprehensive support for open source projects through education, promotion, community development support, facilitating industry collaborations, as well as funding. If you are interested in participating in MOS, please reach out to us. And if you want to submit an invention report or learn more about working with our office, there's a link down below here. With that, I want to introduce our speakers for this webinar. We're very happy to have Professor Elliot Roos. He is an associate professor of robotics and mechanical engineering at the University of Michigan, and Senthil Raj Ayyappan, who is a research engineer in Michigan Robotics. Both of them lead a highly successful open source project called the Open Source Leg, and they'll be talking about this. We have Megan Forbes, who's the program manager of the Open Source Programs Office at Johns Hopkins University. And we're also very excited to have a speaker from NASA, Steve Crawford. He's the Senior Program Executive for Data and Computing in the Science Mission Directorate of NASA. And Steve, I'll hand it off to you.
Thank you so much. I'm going to go ahead and try and share my screen here. So hopefully you can see it now. Yep, seeing nods. It's great to be here. Thank you so much for the invitation and to take part in this. I'm Steve Crawford. I've been working at NASA now for the last 4 years. Prior to that, I was working at the Space Telescope Science Institute, where I was working on the James Webb Space Telescope and the Hubble Space Telescope, and helping to manage our open source calibration software for those missions. And before that, I actually worked in South Africa for 11 years. But while I was there, I started working on the AstroPi project, which is a very large open source project in astronomy. My background is as an astronomer. But talking about some of the open source software and open science at NASA. This is a condensed down talk that I've given previously, because there's so much to talk about in open source and open science at NASA. And so, NASA has been developing software since the beginning. It has been a core part of our mission and what we do. From the early work by Mary Jackson and Margaret Hamilton, and with this example of the Apollo software, which was released openly, everything that we do at NASA depends on software. And so much, of our missions are also tied tightly together with the science that we do. It's not just exploring the universe, but also as part of that discovery, including in their scientific discovery as well. And so each of our NASA missions do have a scientific component to it as well. And the Apollo one with the moon landing and bringing back information and studies from the moon has been such a critical part of the work that NASA does. And today, we also then, this discovery continues, both with technological achievements and with new work. And here's Ingenuity making one of the first, or actually the first flight in Mars as part of the Perseverance mission. And one of the great things about this mission is that so much of its software was made openly available. F Prime is its open source flight control software, and this was released by JPL in 2017. And this, although Ingenuity has ended its mission, it did make, I think, over about 70 flights during a time period, and it was originally only expected to make a handful of flights, and that was even just as a demonstrator. And so it was incredibly successful, but incredibly successful because of a lot of the large amount of open source software that actually underpins the Perseverance and Ingenuity missions. To celebrate Ingenuity's first flight, GitHub and JPL recognized more than 12,000 people that contributed to open source dependencies of the project. On GitHub, they received a Mars Ingenuity 2020 helicopter badge, but it actually just recognizes the huge amount of software that is actually required to actually drive forward some of NASA's missions. And that the contributions from a wide range of different projects, which we have never had, necessarily even thought about their development having an impact on a helicopter flying on Mars. But by being openly available and accessible, have made that made that mission a huge success. And so open source software, especially in NASA science, and due to the nature of Earth and space science, software is integral to every step of the scientific process, from information gathering, from space-based detectors to sharing results. Our planning for missions, our development of missions, our flight and operations of missions all depend upon open source software at different stages. And then once those observations are made, that data is made available, so much open source software is actually driving the discovery, which actually happens from the observations and work that our missions are doing. And with the work of open source software, there's a lot, and especially as researchers, when making your software available, there's a lot of advantages to it. It does lead to increased reproducibility of your work. It is much easier for others to actually see what you're doing, but also reproduce what you're doing to actually better understand your work. There's the potential for reuse of your software, providing other opportunities to really build on your shoulders and actually further enhance software and the scientific work that we're doing. The curation and archiving of software, along with the better it is actually, once the software is open source, it is much easier to archive it. It is also then makes it much easier to also curate the software, to actually even then also to study how scientific software evolves over time, or to actually likewise, if it's open source, it is much easier for others to understand the results that you're producing. And one of the also key advantages of open sourcing your scientific software is also making it easy for others to provide you credit for your work. So much of science is the scientific process is about recognizing others and how you've actually derived your results, and what processes that led you there. And so having the software as openly available also makes it very easy to credit that work and what are the scientific processes. And so one of the things, and this is one part of one of our overall efforts, not just at NASA, but across the federal government in supporting open science, which is the principle and practice of making research products and processes available to all, while respecting diverse cultures, maintaining security and privacy, and fostering collaborations, reproducibility, and equity. There's a lot of different parts of open science. It's not just about everything becoming immediately available, but also how you make your processes and procedures available to others. But also and especially when we're talking about software, there are and can be concerns about security and/or privacy. And so it is important to take those into account when making things open. But we'd actually really like to see people making as much of their research openly available, because we do know that makes it more accessible, and allowing more people to participate in the scientific processes. At NASA, and as part of the Science Mission Directorate, we've set up the Office of the Chief Science Data Officer, which is led by Kevin Murphy, to help develop and implement capabilities to enable open science, to support the continuous evolution of data and computing systems, and to harness the community and strategic partnerships for innovation. And so we're really looking forward to how we engage with the overall community and actually helping people make their science more accessible, inclusive, and reproducible. And we're doing this across 3 different areas or elements to actually help achieve the goals of open science at NASA, which include data and computing services, which are core services for science discovery. developing different services to actually make the science that make it making the science more accessible, both more discoverable so that you can actually find it, making computing more accessible so people can use it when they need it. Looking at data science and AI, especially how we actually implement innovative data science tools to help advance our science and make our scientific information more accessible. And open science implementation. This includes policy development, education, incentives, and advocacy on open source, on open science and open source software. And as part of that, one of the things that we have been doing is sustaining open source software. In 2021, we actually selected 16 different proposals supporting 22 different projects that provide sustainable support to open science and open source software. And projects like NumPy, AstroPy, SunPy, SciPy, along with a range of other projects that actually make sure that the tools that scientists are using remain sustainable. We've actually just closed the call for our open source tools, frameworks, and libraries for our ROSES 24 that actually just closed on Friday. And so we're actually looking forward to funding the next round of submissions to this program. But we do also support a wide range of different activities. And so in addition to the open source tools with the support for open source tools, frameworks, and libraries, we also do support workshops and conferences in our topical workshop, symposium, and conferences. So actually helping groups actually have meetings or support discussions around open science, which can include data challenges or hackathons as well. There are also opportunities for supporting machine learning as well as developing citizen science projects. And two other projects or two other solicitations that we have that are always open, there are no due deadline programs, is our innovative new ways to support open science, our high priority open source science call. This program supports seed funding of around 100K for 1 year to actually help projects get started, to take a look at what ways and what innovative ways to support open science. We also have a supplement for open science and cloud computing, which actually provides to existing NASA awards opportunities to actually further support that the original award or parent award to make it more open, more accessible, inclusive, or reproducible, and also to help groups actually move and adopt cloud computing as part of their practices. We've made over 100 petabytes of NASA data available in the cloud, and so we really want to actually support workflows that actually help make use of this large amount of NASA data, both Earth and space science data that's being made available there. And one other thing that has been really exciting lately is that we have been producing foundation models for science. These have all been open science models that have been created in collaboration with IBM. And these include the most three that have been released in the last year are foundation models for Earth observations based on the Landsat observations, climate and weather foundation model based on Earth observations, large collection of Earth observations, and also a large language model for science. All these models have been released as open source and will also be soon actually releasing a heliophysics model, foundation model as well. As these models are open source, they're also able to be trained for additional capabilities. And so we've already actually seen some groups taking the Earth observation model, for example, and training it to their specific needs of whether or not it's flood detection, locust detection, or a wide range of other activities, which are actually answering their scientific questions. And then one thing, that we are actually also trying to help people adopt open science and open science best practices. And so if a lot of this that I've just been talking about is new to you, we've actually created an Open Science 101 as part of the Transform to Open Science activity to help people adopt these. And this is overall that we're expecting, this is a 5-year mission to accelerate adoption of open science, to increase understanding and adoption of open science principles and techniques, to broaden participation by historical excluded communities, and to accelerate scientific discovery. The first step of this has been the release of the Open Science 101 curriculum. This curriculum covers 5 different areas, which includes the ethos of open science, the tools for open science, and along with the open science best practices for data, software, and results. And so it's a great way, even if you're just at the beginning of your career, or even if you actually have been doing science for a long time, there's a lot of great things to actually learn as part of this curriculum about best ways to actually share your scientific results and how to make your science more inclusive. We'll also be releasing a set of Science Core curriculum as well, and these are domain-specific curriculum for advanced data science skills. And I think with that, that's my last slide. And so I'll hand it back, but I'm certainly looking forward to and happy to answer a lot of questions, both about NASA and the Science Mission Directorate.
Thank you so much, Steve. So we'll do Q&A at the end, and I'll hand it over to Megan now.
Thanks. Okay, so Steve handled the Astra part, and I'm gonna kind of come down to the Aspera part, right? Like the hard work part. Let me go ahead and share my slides. Okay, can you see these? Yeah. Okay, so I'm Megan Forbes. I'm program manager for the OSPO at Johns Hopkins, and we're going to talk about building for the software. We're going to talk about building communities. Like Ashwati, it's one of the topics I like talking about the most. So at Hopkins, the open source programs office, we do a lot of things, everything from supporting GitHub Enterprise for the campus to training to consulting. But if you look at this list, the first and most important task that we've set ourselves is to build open source community on campus. So what we don't want is for Hopkins to just have this archipelago of unrelated projects, but instead we want a group that cuts across departments and schools and labs where everybody can really find value in coming together and supporting one another. So that's really our core mission. Prior to joining Hopkins, I led a project called It Takes a Village. So this project was funded by the Institute of Museum and Library Services in 2018. So they were funding a lot of cultural and scientific heritage projects, open source software projects. So things like repositories, collections management applications. And what IMLS didn't see was a lot of plans for what the projects would do post-grant. Even though by the time the grant ended, many of these projects had lots of folks using them and relying on them and, storing all of our cultural patrimony in them. So the IMLS really had a vested interest in making sure that the projects they funded were sustainable. So there you go, that word again. And, there just weren't a lot of resources in this community. So sort of more on the humanities side, the cultural heritage side, there weren't a lot of resources for guidance in that sustainability journey. So I use the word sustainable. Steve used it earlier. When I say it, this is just how I'm defining it. So when we say it, we're talking about commitment and resources available at levels sufficient for the program to remain viable and effective as long as it's needed. So I'm going to use the word about 20 more times. So that's what I'm talking about. So you might be thinking, this talk was about community. Why do you keep talking about sustainability? And so it is a talk about community. To create It Takes a Village, we had a forum, we published a book, we held workshops, we published a toolkit. And in all of this work, the core finding was that sustainable programs grow from community needs. So if all you have is a cool idea, you will always struggle to gain traction. So I want to walk you through some activities from the It Takes a Village toolkit, because it's very easy for me to sit up here and be like, you should build a community. But the question I will always get in return is like, how do I do that? So the toolkit provides a really nice framework to assess where your program is. And then it has lots of activities to help you move forward. All of these are freely available online. Ashwati said, we'll share out the slides afterwards. There's links, you don't have to like jot stuff down. So the first one I'd like to share is called Who is Your Community? And so if community is at the core of our successful projects, like how do we find out who they are and what they need? So So this is a really foundational exercise. You run through it and then you can use the results in like a million different ways. And so I'm just to tell you how to do it. So get everybody together, get the whole project team together. Give everybody a stack of sticky notes. These can be physical sticky notes. They can be virtual sticky notes on a virtual whiteboard. And brainstorm, who are your stakeholders? This is any individual, group, organization inside your program, outside your program, who is impacted by its outcome and who is interested in its success. So you should have a lot of sticky notes. So kind of faded behind the slide here, you can see a bunch of sticky notes from an exercise we ran. You put them all up on the whiteboard and then you group them together. So you might think these people are sort of similar. We'll call them end users. This groups are kind of similar. We'll call them funders, or, you know, whatever the groups are that you want to have. Once you've done that, then you can take a bunch of different paths. So you might want to brainstorm goals that you have for each group. Like, what do we want to do with this group? What do we want their, you know, outcomes to be? You might want to prioritize them. Project teams are always short on time. And so you have to think about who are the groups that we most want to reach out to? Who are the groups that we most want to have use our application? So we might prioritize. You might map out an influence or interest grid. So you put influence on one side and interest on the other. And whoever shows up in that top right corner, right? Somebody who is heavily interested in the success of your project and who has influence over it, you want to make sure they know what's going on, right? So there's lots of different things that you can do with these stakeholder groups once you've mapped them out. Another activity that I like to do is creating a value proposition. All a value proposition does is it describes the benefits users can expect from your products and services. So this could be a software application, this could be services, you know, if you're providing cloud computing services or a science gateway, right? What are the benefits that users can expect from your product? So that if I'm asking you if you would like to use my software, I have a nice, easy way to describe to you what it does. So you can choose a stakeholder group from who is your community, which you've already done because you did it first. And you might run this a couple of times because you might have a different value proposition for a group of end users than you might have for your funders or your provost, right? So you might run this a couple of times. And then you ask two sets of questions. So you ask questions about the stakeholder group, right? What are they trying to do? What are they actually trying to do? They want to analyze big data. What are their pain points? They can't get the big data, or they can't move the big data around, or, you know, they have too many copies of it, whatever it is. What is holding them back from doing the thing they are trying to do? What are they trying to achieve? So yeah, they want to analyze big data, but like, why? They want to write a paper, they want to get tenure, they want to like win some big award, you know, whatever it is. What's the thing they want to accomplish, right? So this is going to be on like one side. On the other side, these are questions about you, about your program. What products and services are you offering, right? How are they alleviating the pains that your users might be feeling? If the pain is that they don't have a way to move big data from point A to point B, is that a service that you offer? Is helping them do that? How do you help them achieve their outcomes, right? So are you cutting down the time it takes to analyze data so they can publish that paper faster, whatever it is. And then you want to see if it fits. Are the things that people are trying to do and the things that you are doing, do they actually go together? If they do, that's great. You have a good value proposition, you have a good fit. If they don't, that might not be the stakeholder group for you, or it might mean that you want to change that roadmap. If that's a stakeholder group that you really are interested in supporting, that might show you some of the things that you want to put on your roadmap to improve that product so that it's a better fit. And at the end of the day, you can just, here's the Mad Lib version, so that if somebody asks you, why should I use this? You fill out the Mad Lib, you know, this product is going to help this group of users. They want to do this. They want to avoid this pain. You know, they want to have better success this way, unlike those other guys, right? And so this is a really nice, quick way to say to people, you know, here's what our product is about. Then you're going to have a bigger conversation, right? But this is just that very quickly, you know, what can we do for your group and where do we see that fit together? You know, make a plan. The core of It Takes a Village is really, you know, community-based. But if I had to say like the second biggest finding, it would be like, write it down, have the conversation and write it down. So make a plan for how you are going to communicate with your community. Because if you just sort of leave it up to like, well, when I think about it, or when I get around to it, or maybe when something interesting happens, it's not going to happen, right? So make a plan. think about all those groups again, back to who's your community. Think about how you want to engage with them. Do you want to send out emails to people? Do you want to have webinars? Do you want to have open houses? Do you want to have focus group? And then make a plan and stick with it for some period of time, right? If people oh, cool, I'm going to get my quarterly update, then they're happy and they're excited to see it coming, and they know they don't have to call you and find out what's going on. They know they're going to get that. They know you're going to do a webinar after each new release. So they're like, great, I'll get the release announcement, and then I'm going to be able to go to the webinar and really see that code walkthrough, everything that's happening. You do want to evaluate it, make sure, like, are people opening it? Are people coming to the webinars, right? You don't want to stagnate. But again, that consistency can really build trust that this is a program that does what they say they're going to do. They want to reach out to me. They want me to know what's going on. And then you just write it out, right? Make yourself a little table. We're going to do a newsletter. Our community lead's going to be responsible. They're going to do it monthly, and they're going to send it out with MailChimp. So you just have that down there. Put it on your calendar. And again, build trust with that consistency so that people aren't always trying to chase you down, finding out what's happening. You're really putting yourselves out there so that the community can get to know who you are. You really want to welcome people in, right? You don't want your front door of your project to be like a scary crypt that you can't get in. You want it to be super welcoming, like Martha Stewart has designed this front door, right? So what documentation does your program have that supports growing a successful community? Yes, like docs can help you with this. So then you want to prioritize some missing documentation and create it. So a README, for example, right? People come to your repository. You want them to be able to look at the README and understand what is this project? Why should I use it? How can I install it? How do I contribute, right? Really, really basic questions that you don't want them to have to go to 35 different places to find out the answer. They're going to go to your README and they're going to see it. Contribution guidelines. Somebody wants to be a part of your community. Invite them in. Let them know how to do that, right? Who do they email? Is there a good first issue that they can pick up, right? So a lot of this seems like really basic, but as a person who manages GitHub Enterprise for Johns Hopkins University, I will tell you, a lot of repositories do not have these really basic documents, okay? License file. This might shock people. If you don't put a license file, that does not mean that your code is free to use. That means that your code is copyright and only you have permission to use it, right? Put a license on it. So all of these different things, lots of documentation that you can do that you should be able to do fairly easily because you know your project really well. Installation instructions, have somebody else test them out, right? The person like who doesn't work on the project, because I know you know how to install it, but can somebody else follow the instructions and install it? So really basic documentation that just provides that welcoming atmosphere for people to come in and like start getting, contributing to the project. Then once you've done that, welcome more people, right? So there's so many different ways that people can contribute, and a lot of those ways are about more than code. So of course, we wouldn't have open source software applications if we didn't have code. So you want people to write code, you want people to review code. If people aren't ready to start contributing code though, maybe they're going to do some QA tests. Maybe they're going to triage bugs. Maybe they're going to do a translation. Maybe you have people like me who are not software engineers, but I could write something about it. I could give a presentation about it. I can write end user documentation. So there are so many different ways that you can invite people in and really get the community, feeling like they have ownership of the project, that they are champions for the project, and that they're really invested in its long-term success. So this list actually came from the CHAOSS project. So CHAOSS is led by some folks at the University of Kansas, but it's under the Linux Foundation. And they've got lots of metrics that you can use to analyze your repositories. For example, if you want to look at your repositories and see, do they have a license? Do they have a README? They've got all kinds of things that you can use to measure the health of an open source project. So huge recommendation for CHAOSS. This is just one specific tool that they have. All right, diatribe over. Happy to answer questions at the end, and I'm excited for the next presentation.
Thanks so much, Megan. That was so good. Lots of practical information. And like I said, we'll share the slides because she has links to all of those worksheets. So I'm going to hand it over to Elliot and Centaur. And you guys have about 20 minutes or so because both Steve and Megan were really good with their time.
Awesome. Can you like hear me and see my slides and such?
Yes.
Awesome. Those presentations we just heard from Steve and Megan were fantastic, and we like have been thinking about, especially like the things that we're discussing. Megan, you're discussing most recently. We just thought that was really, really great, and we have been thinking about all of those things. And my hope is you will see evidence of our thought in our presentation. So I'm Elliot Rouse. I'm an associate professor of robotics and mechanical engineering, and I'm here with Center Iapan, and he leads this project. So he's a staff engineer within my laboratory, and he's the lead on this open source leg project. So this project can be a little bit different. This is going to be more of a deep dive into kind of one particular open source project that's both hardware and software oriented. And we're going to talk you through kind of the project and how we came up with it, what it is, and then some of the kind of open source aspects of it. Maybe before I do that, I want to just give a quick plug for my research group and kind of what it is that we study. And I would say, firstly, we study kind of basic biomechanical science. So we study the way humans move, the way they walk. We study the mechanical properties of gaits, and we study people's perception and psychophysics around using assistive technologies. But we also build wearable robotic hardware, so exoskeletons and robotic prostheses. And what's helpful about our approach is that the fundamental science questions we answer helps us kind of build kind of novel hardware systems, and then we use that hardware to test kind of fundamental science questions. So this is kind of the kind of pitch for my laboratory, and what we're going to talk about is really just one project within kind of a large part of my laboratory, which is this is maybe like 20% of our work. Okay, so let's think about like robotic prosthetic legs. My guess is you haven't seen very many robotic prosthetic legs in the world. And one of the reasons for that is because telling these machines what to do, their control, is one of the greatest barriers inhibiting their clinical translation. If these machines make a mistake, someone could fall down a set of stairs, and it's a dangerous situation. So because of this kind of near perfect target for control, it's very difficult to translate these systems. Fortunately, we have many different researchers around the United States and around the world developing the control strategies for robotic prosthetic legs, but each researcher has to build a robotic leg to test their control strategies first, because there are no commercial systems that you can buy that will enable you to program the control behavior. So while this has developed many impressive robotic legs, it hinders translation and clinical success because we keep kind of reinventing the same machines over and over, which costs years and hundreds of thousands of dollars. And then when the results are eventually published, it's very difficult to decouple those results from the hardware on which it was used to test. And you can kind of get an idea that these systems are very different from each other. So our goal, this project started maybe in 2017 or 2018. Our goal was to develop a open source robotic prosthetic leg designed from the ground up to be easily manufactured, assembled, and controlled. So we've developed two generations. I'll kind of talk through a little bit of the first generation to give you kind of more of the motivation. And then the second generation is where we are now. It has a few different improvements, which I'll mention. So we designed the open source robotic leg as this tool for controls researchers to test their control strategies. So we wanted it to be flexible and scalable, so it can be used as a knee or ankle or together as a robotic leg. So it's modular. If we look inside, this is the first gen system. If we look inside, we can see it has 3 stages of belt drive transmissions, which are quiet, efficient, and low cost. We use motor technology that was developed when drones were developed, so drones cannot use transmissions. So in order to produce the torque that they need at the speed they need it, drone motors have gotten wide and thin. And as a result, we can take that topology of those motors and use it to our advantage. And so we've done that. We did that kind of in our design, but now that's more common in robotics, is to think of it that way. So we use belt drive transmissions. We had a 4-bar linkage in our ankle, but we've changed that out in the V2, which you'll see. The system has all sorts of sensing capabilities. So sensing for control is very important. So it has the ability to sense the load, so forces and torques kind of going through the leg. We can sense all the information from the motor. So it's current and voltage and torque and speed. We have information about temperature and onboard battery measurement. So the system is kind of fully self-contained and has all the sensing information kind of available if needed for a certain controls researcher. It also has a hardware innovation called selectable series elasticity that I'll talk about for a moment after I talk about the second design. So that's their first design we developed. And then over the last kind of 2 years, we developed our V2 design, which is essentially the same general idea, but it has been kind of redesigned to have a few different benefits. So when we first designed the open source leg V1, the actuators that are in use in the version 2 were not available, so they hadn't been developed yet. So we took the actuators that were recently developed and combined that with a lower transmission ratio in the leg, which just made it become a simpler design, fewer parts, lower cost. Now I don't know why it's advancing on its own, but I'm gonna try to just go back. Now both joints, the knee and the ankle, are mechanically identical, so people can share parts between them. They have the same, or they have increased range of motion. This is generally a more compact and easier to use system that we've just leveraged the design improvements since the technologies that have been developed since version 1. So this I want to tell you a little bit about. This is kind of an offshoot of the project, which culminates in an open source tool that we developed. But one thing people do in robotics is put a spring between the output of a transmission and the load. And the idea is to sense the deflection of that spring and control the force or torque applied by an actuator. In our field, in wearable robotics, these mechanisms, which are called series elastic mechanisms, are, I'd say, hotly contested. So part of our field wants to use this robotics innovation, part of our field does not. And the reason, it has some performance benefits on actuation, but it costs mass and complexity, which are two things you don't want if you're building a wearable robot. So we wanted to build this robotic leg to meet the needs of both kind of groups in our community, those that wanted to use a series elastic system and those that did not. So we designed the open source leg to work with both these configurations, and along that path, we developed a new type of torsion spring, which is a rotational spring. This spring is essentially a disc that fits kind of within the output pulley of the transmission. So it's a compact, low stiffness spring that can fit into the design with no added volume. So it still adds mass. So for those researchers that are thinking about developing a system, they might still be off put by the mass of a series elastic system, but at least in this case, we can add it for no volume. So we thought that was a kind of a nice addition. So while we developed these, here's me using that spring on my desk to give you kind of an idea of how it works. And the schematic below is the open source leg's knee, is a section view, so it's cut in half, and we're looking into the belt drive transmission. So we're looking at the knee joint axis, and you can see the springs can stack inside that pulley, which just enables the ability to have a series elastic version of the prosthesis or not. In developing this spring design, we developed a tool that enables these springs to be designed not only for our application, but for any robotics application. And we took this tool and used it to remake the springs from other research projects and showed that this design produces springs that are smaller and lighter than every case we chose. So it's just kind of a neat offshoot that came from the open source leg project, and it produced this open source spring tool, or we would say it's an open access tool. It's not open source. So for people, this is kind of a little bit about using the open source leg. So here's a participant using the leg in our laboratory. We have a pipeline that enables people to get up and running on hardware and software side, which I'll discuss in a minute, and Cynthia will continue. We have a lot of software infrastructure around using Raspberry Pis. These are single board computers that run the high level control of the system. So we have a set of software tools that leverage this. I want to just quickly mention these. So what we have here is a tool that it creates the image that runs the Raspberry Pi. So it creates its brains. But we created a special version of this image that is made to be convenient and easily deployable. So this image will create a set of instructions that's preloaded with all of the repositories or libraries needed to run the open source leg. But it also includes networking infrastructure where it will connect automatically to a Wi-Fi network that you tell it, like M-Wireless, and then it will automatically email you its IP address. And then that lets you SSH into it and continue development. So this is a repository we have to build this image. If you were to go to this repository and fork it, you would go to the Actions tab. That's what I'm showing here. And if you selected to build now and run the workflow, you would just enter in all the information for your specific Raspberry Pi here. So this would be like your computer name. What do you want your Raspberry Pi computer to be named? What do you want your login information to be? Or do you want to set it up to connect to an additional Wi-Fi network? These kinds of things. You just enter all those in the workflow settings, and it will build the image in the cloud, and then you can download it as a zip file and flash it. For sharing, we've developed extensive infrastructure around sharing full control strategies. So this would be for researchers that have developed a control strategy and now want to kind of disseminate it or publish it or use it as a comparison for other researchers. We can share those control strategies without sharing source code. We have a pipeline to create a shared object file for that, which we're pretty excited about. The system, the open source leg, has been around since 2017 and 2018. It's currently in use by maybe 20 institutions around the world. There's a handful of them listed there. It's also commercialized by Hemotech. This is a little bit of our website, so I want to kind of show you that. So this is our website, opensourceleg.org. It has everything needed to develop an open source leg on your own. So all the solid model files, the bill of materials, vendor information, tutorials for control, tutorials for assembly. It's showing data sheets or kind of anything that you would want or need to build the system, including software demonstrations. So I would encourage you to take a look at that website, opensourceleg.org. So that's kind of probably the most of our project can be seen kind of from that website. And we also have scientific papers that show the technical information of the prosthesis. This is just a little bit about funding. So for anybody who's thinking of deploying their own open source system, so this is a way. We originally were funded from the National Robotics Initiative, where part of the goal was to create scalable robotic systems. That got the project started. And then we kind of continually built on it. And for our last hopefully 2 grants are NSF POSE, which are Pathways to Open Source Ecosystem. That's a new initiative by the NSF to fund the development of open source infrastructure. It's amazing. We wouldn't be where we are without it. So we try to disseminate in other ways. We kind of use trade magazines and popular media, try to just get the word out. We do a lot of demonstrations at conferences. Right now, people are starting to publish papers that are using the system, and that we're really excited about. So that was kind of part of the idea, is that we build this body of literature that helps advance the science. So I wanted to mention a little bit about our commercialization. So the open source leg can be purchased online from Hemotech, which is a small startup that provides research equipment for rehabilitation-related research. To give you an idea of how we structured it, so this is for people who don't want to go through the process of building it themselves. So if someone is less hardware inclined, or they're not, that's intimidating, you can buy from Hemotech. You can get a kit of parts. Well, they'll just send you the box and everything's together, and all you have to do is assemble it. So they're basically taking care of the ordering logistics, or they will sell you a fully assembled open source leg. So it's about $50K for the kit of parts, about $100K for the full leg and support, and our cost is about $20K. And all of that's published online. We're developing custom embedded systems, which is kind of different PCBs and kind of accessories to help streamline the process. And we'll have those sold by Hemotech as well. Okay, so now I'm going to hand it over to Senther, and he's going to share a little bit about the website and community.
Thank you, Ed. So I'm going to talk about how we took an open source project and how we like converted or transitioned to an ecosystem. And this is going to be like a case study of whatever Megan was talking about. When she was talking about, we were both like, yeah, we did that, check, check, check. So we started with an understanding. So we had an understanding of what this community looked like, which was mostly researchers, academics who are trying to get into the prosthetics research space. But then we sat down and we sketched the entire community. And I can't stress how incredibly useful this was, because our understanding and what the community actually was a little bit different. We initially had a WordPress website with a plugin that allowed us to host a small forum. And over the 2 years that this forum was online, we had around 127 people. And you might wonder, if you build something really cool, people will come, but it's been 2 years, and like we are slowly acclimating and getting more users, but it's not, the level at which we grew was not that much. So using this data and other web analytics data, like visitors and unique visitors and all that stuff, we were able to identify these different groups within the user base. And then once we identified these users and like different groups within this community, we actually started questioning, okay, how do we expect these groups to interact within the ecosystem? And what is actually preventing them from, our expectations? And most of these things primarily are related to our existing website and the way we released our software and hardware files. So we took on the task of developing a new website from scratch. So that's our previous website, which was built with a WordPress system with a lot of plugins. It was worked by so many people over a course of like 4 or 5 years. And one of the key goals that we had in mind for this new website that we are building is it has to be scalable, and it has to host an actual community forum, not a plugin that is really small or something. It has to be feature rich and tailored to our specific community. And our previous development workflow involved logging to WordPress and then making edits, and it was very hard to track changes and who made these changes. And if something happened, reverting back to a previous version was so hard without breaking anything that was going on. So we completely wanted to revamp the website from scratch, and we used modern tools like TypeScript, React, and Next.js. And after 6 months, we were able to finally rebuild the entire website. And most of our effort went into creating a community forum from scratch. So this involved creating a seamless, fast, safe way to log in, create accounts, post, and talk about something, which our previous forum had an interface which kind of seemed intimidating for people to casually ask questions. This one has, our new community forum has a much more simpler and welcoming tone to the entire community forum page itself. And our new website also enables us to tailor features, something that we want to do in future, because we have the entire code base developed in-house. So we can add features or support things. If something breaks, we have the knowledge base to fix things as well. We also use GitHub Actions to deploy the website. So all of our code base literally lives in a GitHub repository. And anytime someone merges to our main branch, all the changes get deployed automatically, which was really convenient, and it was safe. We were able to switch between commits and change things around real fast, which was not possible with the WordPress development pipeline. And the next thing we noticed is there was a lack of contribution from other members within the community. Although open source leg was used by 15 research groups at this point, we haven't received any major contributions back to the project. And so far, it has been, it was a one-way process where we add features to the Python library and make them public without any collaborative effort. And I think this might be a common starting point for most open source projects, where it's one way you develop something and you put it out and people start using it, but there's no contribution back. And to encourage contributions, we made it easier for users to contribute back by creating this development pipeline, which involves a specific set of development tools that are totally removed from the actual focus of the project and the actual technical pipeline of the project. So we had a Python library. So we incorporated a lot of development tools that aid in formatting your code automatically or catching these type errors. And if you miss documentation, it would prompt you for, okay, you missed the documentation here, please add it before you merge it back. So these kind of tools made it easier for people to contribute back to the project. We also ensured that our entire code base was tested, allowing users to utilize these tests to be confident whenever they submit a pull request. One of the reasons why we didn't get enough contributions was people who were conducting research with these tools, they were not super familiar with Python, and they always felt intimidating to like publicly support or let people read their code. And this way they can be confident. And we had contribution guidelines, and all of these development tools and this pipeline combined gave them some confidence to like send pull requests, merge their contributions. And another thing that I want to mention is all of these tests that you can see here gets automatically triggered. So whenever someone submits a pull request, these tests are automatically triggered and they give you a check mark or an X. So which makes the review process very fast and easy for us. So we don't have to go through their contribution line by line to make sure that it's safe. We can just let these tests do their thing and we can get an output out of them. And we also wanted to extend the same level of automated testing and version control for CAD files. But the sad thing is there aren't many tools for hardware development, like software. And we were sharing step files of our designs at this point. Step files are CAD agnostic, CAD software agnostic files. They're usually exported towards the later end of the development pipeline for manufacturing processes. The one downside of sharing step files is you completely miss the feature tree, which is a history of changes, basically a history of how this component was actually made, which means someone who downloads this zip file and opens the step files, they have no idea of how the person designed it. They have no way of like reverting back to the original version without actually replacing it. And since we were also distributing compressed file folders of like 1 million files, it was also really removed from version control. And we were using SolidWorks, which posed several problems. Users needed the latest version of the software to open files, and it was also expensive, and it only supported Windows, and it wasn't cross-platform. So late last year, we started transitioning to Onshape. Onshape is a cloud-based cross-platform CAD software. It has Git-like version control. So anyone can go open our designs, make different versions of it, and then if they want to make these changes open source or like merge it with our actual main design, they can contact us. We can merge those changes really easily. So this gives us a confident way to merge things, review things, and also manage our releases efficiently. And this is my last slide. Here are some things that we learned while this transition. The first thing that we learned is understanding that community needs might not always align with the project needs. And for us, this meant developing a website from scratch. And we are not software engineers, and we had to like pick it up. And that basically tells you how good open source software has come. Like all of the web dev tools are really intuitive. They have really good documentation. Anyone can build a really nice website with really good documentation. And building a robust development pipeline for our Python library. This development pipeline has nothing to do with the functionality of the library itself. It's only to encourage collaboration and co-creation. And we also realized that these steps are crucial for the long run. So when you're working on a technical project, it's super easy to get into the mindset of, okay, let's build something really cool and release it. But if nobody knows how to use it, then it's gonna not help anyone. And that basically touches this point as well. So we basically learned how to develop cutting edge tools that are easy to use, collaborative. This means you gotta spend a lot of time writing documentation, which is not the fun part of building these tools, but it has to be done. And this is something we are still working on and getting better day by day. We receive a lot of ideas, bug reports, and feature requests from researchers around the world using this open source like hardware and other modules that we have built as part of this project as well. So we are continuously trying our best to determine which ones to prioritize. And as Elliot always says, it's a good problem to have.
Thanks, Cynthia. Yeah, so that's pretty much kind of what we wanted to share. Like, maybe I'll just conclude by saying, like, I think what's happening right now that we've been really fortunate to kind of ride the wave of is all of these new open source tools that have been developed probably over the last several years. And we kind of made a decision to switch over some of our processes at that time, and that kind of plugged us right in, and that's been really fun. And I think we have Cynthia to thank for most of that, but I'll stop sharing. That's what we have, and thank you for listening to us. By the way, there we go.
Hello. So thank you so much to our speakers. That was a phenomenal presentation. And I was frantically taking notes for myself on the side of things that I wanted to, explore further after hearing all of your talks. So thank you so much. We have one question in the chat, and then I have a couple other ones to kind of go over. I'm going to start off with some, I think, for the group broadly. And then after that, we can kind of just, if someone has something strongly they want to say, they can kind of do that one, or I might pop some questions to each one of you. So I'll just do the one in the chat first. It says, do you have experience with Sloan, POSE, or other grants that support community development? If so, what do you think are the aspects of successful grants in these mechanisms? I hit answer live. So does anyone have experience with those grants? Elliot, do you want to go first?
I can answer. I mean, I mentioned the POSE. So we haven't tried the Sloan, but we've tried POSE phase 1 and POSE phase 2. They're rather short, six pages for phase 1, and I think 15 for phase 2, and they're short in duration. So their phase 1 is 1 year, phase 2 is 2 years, but they're high dollar amounts. So you can make a lot of things happen quickly. I would say the biggest thing that they're looking for is that there's a need, that there's a value proposition and a community that's kind of looking for this, and that kind of you're the right person to do it. And if you can show those things, I think that I think that goes over well. We've had a lot of success and a lot of support from the NSF for at least for our project. I've been kind of blown away by how much support they're really helping us.
Fantastic. Megan or Steve, do you have anything to add? No.
Steve, could you talk a little bit about the grants from NASA that supported?
Yeah, and so so I was going to say I don't have any experience with POSE or Sloan. In a previous life, I did have a little bit of experience with another foundational one, which was a Moore one, and I think so I'll just mention that briefly, and then I'll mention the Sloan ones. But yeah, it's especially when I was long involved with an open source project that was entirely volunteer based, and so it never had any funding actually for pretty much the first 8 or 9 years of it. And I will say, if you're in a situation like that and you do get funding, it is a very new thing. And so, and how that funding affects your governance or other aspects will take time to figure out. And so, but there is also a lot of great models and great groups that have worked through it with the open source, and especially with some of the different funders, whether or not it's Moore or Sloan or CZ or each of the different ones, and as Elliot kind of said, as a funder also, we want to make sure you're successful once you get money. And so, we're always interested in helping you, support you out, and make sure you get the right connections. unfortunately, I can't advertise it here because we just closed, but hopefully some of you knew about it. But our open source tools, frameworks, and libraries is so it's slightly different from the pose calls and the other ones, but this is really for existing projects. So once you're actually becoming an established project that you've shown to have significant usage by the NASA community, we want to provide the sustainability. So which includes some of the stuff of like the bug fixes, the documentation, but also includes some of the aspects of the community management, because that also takes, time and effort. And so that, is some of the costs that we allow as part of that award. Because as I said, like, different projects and different people will prioritize different things in there. But if you do want to build that network and community, that not only takes time, it also takes, I'd almost say also skill as well. And I think, with especially Megan's great talk, there is a lot of expertise out there, which I'd always encourage people to, learn about and develop over time. But we also have two other opportunities, and these are, as I said, one of them is our supplement for open source science, and this is for projects that already have a grant and want to do a little bit more. And then the other one is our high priority open source science. And these are really for innovative projects. So like when you're really at the start, you don't have a community yet, but, is this going to be something that's going to work? And, and then hopefully later you would graduate to an OSTFL award or find other, opportunities to support it. But really for that innovative seed funding when you don't really have much of anything yet.
Thanks. Megan, I'm going to put the next question to you because I feel like Steve gave me a nice segue. Do you have any recommendations for groups who want to find a community lead, and what maybe traits or characteristics a good community lead might have for a project?
Sure. I think sort of the first thing actually that you said, like committing to finding a community lead. So like it's really, committing the resources and the time for somebody to do that work is sort of, even the sort of critical first step, because it does, often become sort of an afterthought for people, or, I'll do when I have the time, or I need to wait until X, Y, or Z future thing that never happens. So, starting it early. And honestly, other than that, it's just, somebody who's comfortable talking to people, somebody who is happy to go to meetings and give presentations and go to conferences and scared to stand up in front of people and talk, right? So sorry, introverts, it's not always the best role. So looking for those people who are, extroverted, also looking for people who are really good at talking to both sides. So like in the corporate world, it's like the sort of developer relations role where you have somebody who can talk to software engineers and understand why things happen the way that they do, why choices were made, why the roadmap looks like it does, why this release is going to be late or awesome or whatever. And then also can talk to users and really understand the subject matter. So if a user comes and says, this is the problem that I'm trying to solve and this is what I'm having, there's that understanding. So really being able to be that bridge between the community and the project. And then, a lot of times it's, especially when communities are getting started, there's a little bit of pulling teeth. So there has to be that certain element of like shamelessness, like I'm going to hound you into being a part of this committee. I'm going to, pull this participation out of you until such time, right, as then hopefully that person can step back a little bit and let the community start to take ownership. Somebody does a presentation and they don't check with you first, and somebody, goes out and has that conversation, which is sort of that ultimate goal. So, but in the beginning, there's a lot of that, like, oh, you're going to participate. I'm going to put you on this list. I'm going to make you come to this. So there has to be that, you just have to be comfortable talking to different levels of people. We need to have a conversation with an end user who's in the little windowless cubicle. I need to have a conversation with the, vice provost for research because I'm trying to convince them of something, right? So a chameleon, DevRel, extrovert, unicorn prancing around your project, right?
Elliot, just as a segue to that, I'm wondering if you could talk a little bit about how Centaur came to play that role for the open source leg, if it happened organically or there was kind of like a decision point.
Oh yeah, for sure. That's a great story. So I get a lot of emails on about the open source leg project from people around who find it and say they want to get involved. Actually, I have something to say about that later, which we can get to. But Centaur was one of those people. So he emailed me. This is a long time ago. I don't even know how you had found it at that point, but it was probably like, I mean, the website was up, but it wasn't well known at that time. And he emailed me kind of wondering if he could get involved. This is how I remember it. He really wondering if he could get involved. I said essentially the same boilerplate email everybody gets, which is like something along the lines of thanks, but no thanks. And then he started working on his own anyways. And he built a test in Gazebo and a visualization of the open source leg walking in a simulated walking environment. So really cool, like just really neat thing that no one had done yet. And he messaged me and he said he had done that. And then he said he had an idea for a change in design, which was the V2. And it was the same idea that we had already, so that we were planning to do. So that felt like there's too much, like I got to get this guy here. So I hired him. And now he is like leading the post 2, which hopefully gets awarded very soon.
That's awesome. I feel like my next question kind of relates to that, being that you found him kind of as a community partner from your project.
Yeah.
What are the aspects of a strong community forum for OSS projects? And Centaur, you had mentioned that there's some new OSS tools that are developing. So what recommendations do you have, as a two-parter, what recommendations do you have for other groups exploring tools for their forums?
So we are investing a lot of time exploring whatever that comes out of GitHub. GitHub has been super.
I can do it. I'll share you.
Yeah, they've been pushing a lot of these developer tools, and something that we've been investing a lot of time is the project boards and how we could use that to basically show people what projects are open and they don't have assignees, and our roadmap as well, as Megan was talking about. So GitHub is a really nice place where you can have discussions. You can show them the roadmap, what kind of issues we are trying to fix, so that we don't want people to be waiting around. And if our roadmap says we are going to fix it, we're going to try our best to fix to that roadmap. But yeah, that's the project board I was talking about. And other OSS tools are just mostly tied to GitHub. GitHub Actions is a really nice feature that people get for free. So it's essentially spinning up a virtual machine every time someone commits or does anything with your code base. It spins up a virtual machine which you have access over. You can run any kind of tests, any kind of review process in there, and then merge your code. And we also have these kind of tests where, since ours is a Python library has multiple dependencies, and each dependency has its own dependency. And it's basically a huge dependency tree, and we're obligated to make sure our library is safe. And we run a bunch of safety tests with Safety CLI, which is a public repository of all the vulnerabilities in Python libraries. So we use that index to make sure, okay, this particular version of that particular library, that dependency has an issue, and we flag that, and we don't merge that code till that is resolved. So we have these kind of different bots that GitHub has. GitHub has its own marketplace where you can look at these different bots, which you can plug into your open source code base, and that will basically check these things for you, like safety. And people also are super particular about how variables are named, and tabs versus spaces and all that. So we try to fit into the PEP 8 style guide. So we have bots that check these style guides so that nobody gets annoyed of how different variable names are and stuff.
Awesome, thank you. So my next question, I kind of want each one of you to touch upon, if you guys don't mind. So maybe Steve, I'll start with you. If you have any thoughts on what the top 3 drivers are for community success. So as we've been talking about throughout this webinar, I feel like a lot of successful communities evolve differently over time. And so are there any kind of key foundational aspects that people should consider for their project? So I'll start with you, and then maybe Megan, if you want to go, and then Elliot and Cynthia, if you want to go after.
I was gonna say, yeah, it off the top of my head, I'd be probably rambling if I talked about three. So I might just go with one, which has multiple parts, which is being welcoming. You know, really, you know, when new people come to your project, you know, when someone does that first commit or that first pull request, you know, being welcoming for that. It is a big barrier for people to kind of overcome to get to even posting an issue or posting a comment. And it can be a lot of effort on a maintainer as well to try and actually be addressing these as well. But you know, having the documentation, as Kai mentioned, of like how to make a contribution, your first contribution. So people don't even need to, you know, necessarily ask, but they can kind of see, and having statements about whether or not you welcome contributions. You know, and then when people do make contributions, being, welcoming and kind, especially when we talk about the diversity in open source software, it is particularly dominated by certain groups, and it is easy to, a lot of biases can actually slip into that. And so, that's one of the things that, I think, at least on the projects I've seen that have been most successful, is when they've been very welcoming to those coming into the project, and thinking about how to be more accessible and inclusive to all the different type of people who might be interested in contributing.
Thank you. That's an amazing answer. Megan, do you have anything else? Like, I feel like that was such a great one. But
I know.
like, you have so much knowledge to share.
And it's like, it's so foundational, right? Like, be kind, be welcoming, like, would that we were in a place where you didn't have to say that, but do that, everybody. Be kind and be welcoming. Thanks, Steve. So the only things I'll add, I've sort of already said them, but the one is you have to care about it, right? Like, you have to actually put in the work to build community, and having it happen 5 years later, or, something that you don't think about, it's going to feel tacked on. And so you just really want it to be an integral part of what you do, just like writing code, that, thinking about the community and how to build the community and how to share, right? Like, that's why we open source stuff. So thinking about it from the beginning. I also think it's important to show your community like a path for growth. So going from, as Steve said, they're kind of peeking in the window, they're grabbing that first bug, but then letting them see this path. You commit your first bug, now all of a sudden you're on the technical committee, you're going into a committer, so that they can see, growth in that community. People have their own personal motivations for doing things, but people like to be able to say, oh, I'm a committer on this project, or, I did this X, Y, and Z thing. So providing them that pathway, I think, is also really important.
Elliot, Cynthia, do you want to also address what you think our top 3 drivers are?
Yeah, I'll say a driver, or like one that I think that was really surprising to me, and I'm like continually like up against this, which is, so this is especially true, I think, for hardware projects, open source hardware projects, also true for software, but I think especially true for hardware, is that the path to actually execute the project has to be incredibly easy and easy to follow, no errors, few steps, aggregate, everything's already ready. Like, people just won't do it. Like, if you leave, the gaps are too big between steps, people just bail. So if you really want people to use your work, you have to make it as easy as possible. And that's much easier than like I was originally thinking.
Awesome. Dora, did you have one to add?
Well, another thing on like whatever Elliot said and also Steve said is it has to be really easy and to contribute back as well. It shouldn't look intimidating. It has to be really easy And I've spent a lot of my time trying to like tell people it's okay, like people write Python code and they're so nervous to like let other people read it, and they always preface it by saying, like I didn't spend too much time on it, just it just works, don't worry about it. But I just want to convey that it's okay. We start at different levels, it's okay. Just contribute it back. We can work together to like merge it. So that's the idea. So everything has to be super easy to follow, super easy to contribute back. And we have contribution guidelines, licenses, how we expect contributions and all that. These are pages that took a lot of our time to like write it and put it together in a way that it doesn't look intimidating. So all of them are on the website, but yeah, that's one of the things that I've noticed.
Awesome, thank you. So I think we have time for maybe like one or two more. So I kind of wanted to explore, I feel like going off of from the community forum and community drivers question, maybe exploring a little bit, Megan had touched upon it, around communication plans for projects, and what are some ways that maybe teams could track the impact of their projects that they're having, and how they can kind of merge those two together, communicate what they're doing, and then lead that to talk about impact and story of the project that they're working on. So I'm going to open that one up to the floor, whoever wants to start that one.
Well, I'm gonna jump in because Megan's answer also from the previous one also made me think about something which kind of relates to that, which is, providing that recognition. And, especially when we're talking about scientific software, making your software citable, and or, producing some kind of publication with it. And, so there are there's a wide range of different journals that do now accept software papers. There's things like the Journal of Open Source Software, which, you can also create a DOI, a digital object identifier for your software at Zenodo, which has great linking with GitHub to do it automatically. And these are all ways for people to, at least especially in the scientific fields, to get credit for their work and credit for their contributions. And so that, we do actually recognize more than just the publication as meaningful scientific work. And so, yeah, that's making sure people are able to get recognized for it is a critical part in there.
Thanks. Megan or Elliot or Centaur, did you have anything to kind of add about communication plans and tracking impact?
That's a huge plus one for Steve, because I think that also gives you the opportunity, like not everybody always makes it onto the paper, but more people, can have recognition in the GitHub repo and the citation and things like that. So it really lets you share that recognition across a broader group of people.
Yeah, I would just say, I think that's such a cool idea, like the GitHub sharing and contribution badges and all of that. Like we haven't done much of that, and we haven't had much contributions back yet, but we're kind of working on that. And I think that's really cool. We haven't done a ton of communicating either. Like our community is, maybe 20 to 40 PIs around the world, and including grad students, maybe like 100 people of like actual people putting their hands on these machines. And so we haven't done a super good job of like communicating and grouping them. So that's kind of on our radar for the next POSE project, is to kind of get that a little bit more organized.
Awesome. So I feel like we're nearing the end of the time. I wanted to kind of end on a question. Maybe if any of you have any continuing reading or other open source thought leadership recommendations that you'd want to recommend the audience to explore after hearing this webinar, just to kind of keep the conversation going and kind of any dialogue you have. So, I mean, you can feel free to just say them, or we can put them in the chat and share them afterwards. But do you have any other reading or thought leadership that you are exploring on kind of this open source community building?
I highly recommend the chaos metrics that Megan also mentioned. This is the third time I'm looking at the same recommendation. So we also tried to incorporate it but we thought we still have enough time to like grow and then do it. We don't want to make ourselves sad by doing those metrics right now. But that's something is in our radar. And there's also Open Collective. So if you want to raise money with donations and like bring in transparency in your like financial management, Open Collective is another really nice place.
Awesome. Megan, did you have any, or Steve, do you have any other ones to add?
Well, Steve put it in his presentation, but the Open Science 101, it's 5 modules. It's just, even if you already know it all, it's just really great to see it laid out in such a way that it can be easily communicated to other people. As always, like, why should I spend my time on this? Why should I do this? Like, it's so beautifully done. So I hugely recommend Open Science 101 to everyone. Free, of course. And then I'll toot my own horn. So it takes a village. So just itav.lyrasis.org. There's tons, there's like 80 some odd activities there. So if you need like to figure out a governance model, figure out how you're financing your project, any of those things, there's tons of stuff up there.
Awesome. Steve, do you got any that we didn't mention already?
I mean, I was going to go with the easy one of tops, but then Megan did it for me, which is even better than I could do. And at the we have developed tops openly, and so it is actually on GitHub. And at the end of the modules, we do have like further resources, and so that's another good reason to go to it. And I'll drop that link into the chat. And we have both the online MOOC and the we also have in-person and virtual training, so you can take it in any way you want. And I then had one other, and the chaos work is also a great one. And of course, now I had one other one in my head, and I'm blanking on it. But I'll if once I remember it, I'll send it to follow up about it.
Yeah. Awesome. Well, Ashwathi, did you have any other questions? I turned to you as if
We're in the same room, which is why she turned to me. But no, I think we're actually, you know, kind of at time and ready to wrap up. I just want to say thank you. This was super generous of all of you to, you know, spend your time with us. And the slides were so informative and kind of like had a lot of practical tips. So we will share your slides if you share them with me with all the participants, and then we'll also post the recording online. But thank you so much.
Thank you so much, everyone.